everyone. As you can see, this is our presentation on our research about automatic number plate recognition system. So, um, uh, so let's start by understanding the challenges of automatic number plate recognition systems. As you can see, license plates vary significantly across regions in terms of size, color, font, and layout. This makes it difficult for traditional ANPR systems to accurately recognize them. Accurate ANPR systems are crucial for law enforcement, traffic management, and toll collections. However, current systems often struggle in challenging conditions like poor lighting or low image resolution. To address these limitations, this research focuses on using advanced deep learning techniques to improve ANPR performance. Uh, primary objectives Our primary aim is to develop an advanced ANPR system that significantly improves accuracy in recognizing license plates, even under challenging conditions like varying lights, occlusions, and diverse plate designs. Uh, we aim to optimize the system's processing speed to enable real-time operation for applications like traffic monitoring and automated toll collection. Um, we hypothesize that applying deep learning models, specifically CNNs and RNNs, will outperform traditional image processing techniques in terms of both accuracy and speed for license plate recognition across varying conditions. Um, Now let's delve deeper into methodology we employed for this research. Uh, Deep learning based approach. We adopted a deep learning based approach combining the strengths of CNNs and RNNs to tackle the complexities of license plate recognition. CNNs excel at extracting spatial features from images, while RNNs are adept at handling sequential information like characters in a license plate. Diverse dataset. We utilize a large and diverse dataset of license plate images collected from various regions and under different conditions to ensure the model's robustness. Data augmentation techniques were applied to expand the dataset and improve the model's generalization capabilities. Uh, as you can see in the abstract, our research focused on improving the accuracy and efficiency of automatic number plate recognition systems. We achieved significantly higher accuracy compared to traditional methods, especially in challenging conditions like poor lighting and partially obscured plates. Our optimized model also demonstrated real-time processing capabilities, making it suitable for various applications. This highlights the effectiveness of deep learning techniques in enhancing ANPR systems. Now let's delve into the results of our research discuss their implications. Enhanced ANPR performance. As you can see, our deep learning based ANPR system achieved a significant improvement in accuracy compared to traditional methods. The model demonstrated robustness in handling various lighting conditions, occlusions, and plate variations. The real-time processing capability of the system is crucial for practical applications, broader adoption of AI in traffic management. The success of this research highlights the potential of AI-driven technologies in transforming traffic management. Accurate ANPR systems can contribute to improved traffic flow, enhanced law enforcement, and the development of smart city infrastructure. Future directions. While we have achieved promising results, there is still room for improvement. Future research will focus on expanding the system's capabilities to handle multi-language license plates and challenging environmental conditions. This will further broaden the applicability of ANPR technology across different regions and scenarios.
Yeah, Vedansh, you're not audible. I think your mic. You have to unmute your mic. Vedansh, again, it is like you have to unmute your mic.
Sorry, ma'am.
Hello.
Excuse me, ma'am. I'm
Yeah.
sorry to interrupt.
Yes. So in previous automatic number plate recognition systems, we various techniques were employed. So in our literature survey, we focused on analyzing the most common methods used across the field, and the most common methods were using CNN and batch normalization, which enhances the performance and improving model coverage and accuracy. And another common approach for identifying high resolution imaging was for high resolution imaging was the detection of morphological operations, which was prevalent in earlier systems, and play a crucial role in improving image pre-processing. Next slide, please. So our proposed system is a low-cost, high-performance automatic number plate system utilizing Raspberry Pi. The system combines OCR and CNN capabilities to deliver the result that rival traditional high-cost automatic number plate recognition systems. This compact design makes it more accessible and affordable, opening doors to widespread adoption. For example, the enforcement and traffic monitoring systems. Now here we are comparing the different camera modules for ANPR systems. We find significant difference in performance and cost. For example, as you can see for the specialized license plate system, the energy consumption and the cost is very high compared to general purpose cameras. Now, while comparing this, we can see that the general specialized license plate cameras are 60 times more expensive and consumes 8 times more power than general purpose camera model. So our research paper focuses on using general purpose camera model and enhancing its techniques to capture more accurate information.
Okay. So the methodology section outlines the approach taken to develop ANPRs. We are using Raspberry Pi and a camera module. This includes both hardware setup and image processing pipeline necessary to ensure accurate license plate recognition. The hardware setup consists of a Raspberry Pi, a camera module. So the Raspberry Pi serves as the central processing unit for our ANPR system, handling all computations related to image processing and recognition. The camera module is the primary sensor used to capture vehicle images for license plate identification. The Raspberry Pi camera module is particularly well suited for real-time processing, making it ideal for our application. The hardware configuration consists of to set up ANPR systems begin with inserting the micro SD card with the Raspberry Pi OS into the Raspberry Pi, connecting peripherals like monitor, keyboard, and mouse to use USB ports and power onto the Raspberry Pi. Next, connect the camera module to the camera port, ensuring the ribbon cable is securely attached. After booting up desktop environment, enable the camera interface and configure necessary settings using Raspberry Config 2. Image processing pipeline is the critical to extracting license plate for from our captured images. The first is image acquisition, where the camera module vehicle images are specifically frequently captured on frames. So the initial idea was to take images, but later on we moved on to videos to just take by frames per second. Then the pre-processing on the image, then the license plate is detected. The detected place is then segmented into characters, and by pre-trained OCR model, we just extract the character. So the grayscale conversion, the first step is to converting the color image to grayscale. This reduces computational complexity while retaining the essential features needed for subsequent processing. The grayscale conversion is done using the formula of text gray is equal to 0.29 into R. The RGB format is multiplied by the hex numbers. Then Gaussian blurring. Gaussian blurring is applied to the grayscale image. This process reduces noise and smoothens the image, making it easier to detect and recognize the license plate. The Gaussian blur is computed by convolving the image with a Gaussian kernel, which gives more weight to pixels near the center of the kernel. Then next is bilateral filtering. Bilateral filtering is used for further smooth the image with preserving edges. Unlike linear filters, bilateral filters consider both spatial proximity and intensity similarity between pixels. This ensures that edges like those of a license plate remain sharp while noise is reduced. The next is edge detection. It is a fundamental technique used to locate object boundaries in images. The canny edge detector is employed to identify significant intensity changes that make the edge of license plate. The process involves finding local maxima in the image gradient, which helps in outlining the segmenting the license plate from the background. Then next comes the corner detection, used to identify the region of interest (ROI) containing the license plate using a function like find contours from OpenCV. The contours of the pre-processed image are detected, allowing for precise localization of the license plate. Else, if we directly go for OCR, then it is used to capture the car's name or the company manufacturer of the car as well. So by CNN-based convolutional neural network, just taking out the number plate helped us to increase the accuracy, identify and localize license plate with the image by learning distinctive features such as characters on the plate. Then is the integration of pre-trained OCR model. Instead of training a model from scratch, we used a pre-trained OCR model for our ANPR system. We use PyTesseract, a Python-wrapped Google Tesseract OCR engine to extract text from license plate image. The first part of it is text extraction. The pre-processing image is loaded into PyTesseract using image to string function, which extracts license plate number. Text post-processing contains the once the text is extracted, it undergoes post-processing to clean up the noise and special characters. Regular expressions or pattern matching are applied to validate and format the license plate number. OCR integration in ANPR workflow is run after the license plate recognition is identified and cropped. The extracted text can then be processed or stored as needed. Using these steps, ANPR systems effectively process vehicle images, allowing for robust and accurate license plate recognition through the integrated OCR model.
Once a vehicle, once a vehicle's
Yeah, I think you can go ahead.
Once a vehicle's license plate is recognized by the system, the information is securely transmitted to either a designated email address or an external IoT cloud platform for further processing. This transmission leverages common network protocols like SMTP for email and HTTPS for cloud API interactions. To ensure the data remains secure during the transit, we employ encryption and authentication mechanisms. For instance, on the slide figures on the slide illustrate the implementation processes. Figure 2. This figure details the installation of SMTP protocol on a Raspberry Pi to enable email-based transmission of license plate data. Meanwhile, another figure shows the setup process for configuring the SMTP to ensure that recognized license plate information is sent securely and efficiently. Uh, our ANPR system demonstrated impressive accuracy in controlled environments, matching or surpassing the performance of established commercial solutions. However, the complexities of real-world scenarios, such as varying lighting conditions, obstructions, and image blur, introduced challenges that can potentially impact system accuracy. It's essential to acknowledge that the choice of camera module, particularly in compact form factors, can influence both accuracy and processing speed. While this trade-off between the cost and performance is a critical consideration, our system has achieved a commendable accuracy of 90.9% as demonstrated in the figure. Uh, while implementing
Yeah, Siddharth, you can go ahead, Siddharth. You're
uh,
audible.
yes,
Yeah.
While implementing and testing our ANPR system, we encountered several limitations and challenges. Firstly, our reliance on static camera setups limits our ability to capture license plate images from fast-moving vehicles or from different angles. Secondly, external conditions like poor weather and glares can distort image quality, impacting our OCR's accuracy. Thirdly, the processing power of Raspberry Pi 4 restricts the complexity of our CNN model and image preprocessing algorithms, limiting the scalability and real-time capabilities. To address these limitations, we propose following areas of improvements and future research directions. The first one is dynamic camera adaptation, using the PTZ cameras or multi-camera setups to increase resilience and adaptiveness. Second, the advanced visual processing, researching advanced visual processing methods such as DL-based image grinder and denoiser, edge computing, and parallelization, exploring solutions for edge computing and parallelizing deep tasks to avoid overloading of Raspberry Pi 4, and data augmentation and model training, using data augmentation and transfer learning to increase variance in training data and improve OCR model generalization, and IoT platform integration, integrating our ANPR system with IoT platforms for smooth transmission, storage, and real-time analytics. By addressing these limitations and exploring the areas of improvement, we can move our ANPR system toward a more resilient, flexible, and scalable solution capable of addressing various corners, cases, and applicable scenarios.
Now I will talk about the sequential pipeline method. Library installation occur in a linear order. Each library must be installed completely before the next one begins. This process, though straightforward, results in longer installation times when there are many dependencies involved. Highlight the downsides. While the method is easy to implement and manage, it does not make the best use of available system resources. With only one task running at a time, multi-core processor are underutilized, leading to the inefficiencies. Talking about the multi-thread approach, on the other hand, introduces the parallelism into the installation processes instead of installing libraries one after another. The benefits of multi-thread approach will be enhanced efficiency, better use of resources, and performance gains. Comparison of these methods will be the in contrast to traditional method, the multi-threaded approach not only speeds up the process but also scales better with larger workloads. Uh, and it reduces overhead and minimizes the ideal time, leading to a more efficient and responsive system. With the integration of ANPR, the pipeline-based integration. In the context of ANPR systems, a pipeline-based integration organizes processing stage like image processing, license plate detection, and OCR sequentially. Talking about the advantages, this method is simple to understand and implement. It allows for easier maintenance as each stage is modular, making update is straightforward. Resource management is also more controlled. Uh, um, the considerations will be it relies on sequential processing. It may introduce latency, particularly if any stage requires significant computational resources. Additionally, it limits the parallelism under utilizing available CPU cores. The multi-threaded integration. Multi-threaded integration approach in ANPR systems Assign each stage of processing to a separate thread. This allows the stages to run concurrently, increasing throughput and reducing processing times. Advantage will be the multi-threaded multi-thread makes better use of multi-core processor, resulting in faster overall performance. Dynamic resource allocation is also possible, as resource can be allocated based on workload demands. Consideration: the approach requires careful management of thread synchronization and communication to avoid issues like databases where multiple threaded want same memory locations. Uh, the the added complexity in handling concurrency and the potential overhead for context switching. uh, Last part is conclusion. We have explored the design and implementation of a low-cost ANPR system using Raspberry Pi and a camera module aimed at enhancing traffic law enforcement and automated toll collection. By integrating OCR and CNN, the system achieves promising accuracy under various system. While the current limitations include static camera position and the computational constraint of the Raspberry Pi, this project lays a strong foundation for a future enhancement like dynamic camera adjustment, improved image processing, and IoT integration. Thank you, everyone, and thank you, Dipti ma'am.